Welcome. Please allow me to take you through the periodic table, the trends across the element group 3 or period 3 elements, the trends down the groups. We are going to talk about the groups that consist of the metals and the groups of the halogens and the group of the halogens. So in this video we are going to study the following: the basic information for understanding periodic table. So we are going to talk about the basic information that you need, and then after that we are going to look at the gradation in properties of metals. So the properties, which are these? The properties is the atomic radius, ionic radius, melting and the boiling point down the group, electrical conductivity down the group, ionization energy down the group, and the reactivity of metals down the group. We will do the same for the nanometals, that is the halogens, and then finally we will talk about the trend across period 3. Now I want to look at the basic information that we need to have in our mind: the structure of an atom. The atom is made up is made up of two major parts. That is the nucleus, which contains the protons and the neutrons, and then this region which contains the electrons, the one we call the energy levels. Therefore the atom is made up of two regions: a small central part called the nucleus, and the larger region surrounding the nucleus. The nucleus consists of protons and neutrons. Very, very critical to understand what is happening. So it is also important to look at the nucleus itself. The nucleus contains of the protons, which are positively charged, and it also contains the neutrons. Neutrons does not have any charge, so they are a neutral. And then we have the outer region where we have electrons. Electrons are negatively charged. So why am I taking you through this? I want you to understand that these electrons are held in their orbitals here in the energy levels by the force of attraction from the nucleus. The nucleus is positively charged, they are negatively charged. Therefore this positive charge is pulling the electrons towards the center. That's why they are there. They are orbiting and rotating around the nucleus or around the energy levels. Another thing I want you to understand is this: the number of protons is equal to the number of electrons for any given atom. This makes the atom to be electrically neutral. Very important. So now know that the number of protons and the number of electrons, they are equal. Very correct. Very important. Then now that takes us to define what we call nuclear charge, because I'm going to talk and mention nuclear charge again and again. So that's why I want you to know the definition of a nuclear charge. A nuclear charge is the total charge of all the protons in the nucleus. So nuclear charge of an atom is positive charge on the nucleus of an atom. It has the same value as the atomic number. Please note that the nuclear charge has the same value as the atomic number. So if the atomic number of an element is 12, then the nuclear charge is 12. If the atomic number is 11, the nuclear charge is 11. Don't forget that. It is going to be very important when we are going to talk about the trends across the period. The nuclear charge comes in to help us understand. Right, so let us look at this. These are the elements across the period. period 3. We have sodium to argon. So we want to first understand look at the electron configuration. The electron configuration for sodium is 2 to 8 to 1. Look at the outermost energy levels. Here is 1, 2, 3, 4, 5, 6, 7, 8. So as you move across the period, the atomic number increases actually, because this is 11, 12, 13, 14, 15, 16, 17, 18. So if atomic number is increasing, it tells you that the nuclear charge increases. If the nuclear charge increases, the force of attraction, the force increases. Very important. So therefore, the nuclear charge increases as you go across the periodic table, due to an increase in the number of protons. Why do the number of protons increase? Because there is an increase in an atomic number as you move across. Very important. Another basic information I want you to have is the simple periodic table. This is group 1 elements down the group. So this one is, we call it down the group. When you have hydrogen, lithium, sodium, potassium, this is group 1. We call them group 1 because they have 1 electron in the outermost energy level. So you can see hydrogen has got only 1 electron, lithium has got 1, sodium 1, potassium 1 in the outermost energy level. Group 2, they are called group 2 because they have 2 electrons in the outermost energy level. So 2, 2, like that as you go across the period. So this one is period 1, this is period 2, and then we have period 3. So period 3 starts with sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So across the period, down the group, very important to see and note the difference. Another important information I want you to note is that elements with the same number of occupied energy levels belong to the same period. Elements with the same number of electrons in the outermost energy level form a group. Therefore, they belong to the same group because they have the same number of electrons in the outermost energy level. Very important. Another information I want you to have is the ion formation. How do the elements form ions? How do they form ions? So atoms with an electron configuration of 2, 2.3 and 2.8.8 are said to be stable. That's right. But the atoms without this electron configuration, which we call the octet and the duplet. So this one is the duplet, octet electron configuration. Atoms without this electron configuration tend to attain this stability by either losing or gaining electrons. That's correct. The charged particles formed when atoms gain or lose electrons are called ions. When an element loses electrons to be stable, it becomes either negatively charged or positively charged. So the positively charged ions are called cations, and the negatively charged ions are called anions. Metals mostly lose electrons to form positively charged ions, while nonmetals gain electrons to form negatively charged ions. So before examples of an ion formation, let us look at sodium. Sodium forms an ion by losing one electron. This electron here, the outermost electron, is lost because it requires a lot of energy to gain 7 to become stable, to have an electron configuration of 288. But it is easier for it to lose 1 to become stable. Therefore, it loses 1 electron to become positively charged. So the charge here is positive and the electron configuration is 2 to 8. If it is chlorine, chlorine is atomic number 17, so it reacts by gaining 1 electron. So chlorine gains 1 electron to have electron configuration of 288 from the previous the atom, which has 287. So look at this. The electrons that were there, the 17, are marked using the X, and the one that has been gained is the dot. Now you can see it has 18 electrons with 17 protons because the electron has been added. So when an element gains electrons, it becomes negatively charged. Another important information I want us to have is the definition of an atomic radius, ionic radius, ionization energy, electron affinity. What is an atomic radius? Atomic radius is the distance between the center of the nucleus of an atom and the outermost energy level occupied by the electron or electrons. So atomic radius of an element is the distance from the center of the nucleus. Now the atomic radius is from here, the center of an atom, that is from the center. This distance from here up to here is what we call the atomic radius. What about the ionic radius? After the atom has lost an electron, or after the atom has gained an electron, now the distance between the nucleus and the outermost energy level of the ion is what is called an ionic radius. Ionization energy. Ionization energy is the minimum energy required to remove an electron from the outermost energy level of an atom in gaseous state. So the energy sodium requires to lose an electron, the energy required for magnesium to lose 3 electrons is called ionization energy. So that is the minimum amount of energy required for an element or for an electron to be removed from the outermost energy level of an element in gaseous state. What is electron affinity? Is the amount of energy released when an electron is added to a neutral atom. So when an element gains an electron or electrons, that amount of energy that is released is what is called electron affinity. Electron affinity is the amount of energy that is released. The trends down the group. We want to look at now the group, because groups, we have groups containing metals and groups containing nonmetals. So that's why I have specified that now we are going to look at the trends down the group of metals. Generally metals, they have similar kind of trend down the group. So that's why if I am talking about group 2 or group 1, the trend of group 1 will be generally the same as that of group 2 metals, group 3 elements, group 2 elements, group 1, they will have the general trend down the group. The atomic radius and ionic radius having, I want to assume that now you know what is an atomic radius and ionic radius. Therefore, what happens to the atomic radius down the group? the ionic radius and the atomic radius of metals increase down the group. That is very correct. Why is that the case? The reason is that there is an increase in the number of energy levels down the group. For example, this one, let us use from beryllium to calcium, that is in group 2. The atomic size, the atomic radius increases down, because remember the energy levels are increasing down the group. If it is in group 2, group 1, lithium is atomic number 3, sodium is atomic number 11, potassium is atomic number 19. Lithium has, let us look at this diagram. Lithium has how many energy levels? 1, 2, because it is atomic number 3. Sodium has 1, 2, 3, and then potassium has 1, 2, 3, 4. So down the group, as you can see, the atomic radius, the distance from here to the outermost energy level, increases from lithium down to potassium. Now, because the atomic radius increases, because the number of energy levels, these energy levels, is increasing down the group. So look at the distance from lithium to the outermost energy. Sodium here, the nucleus to the outermost energy, the nucleus to the outermost energy. The distance increases down the group. So the atomic radius increases down the group because the number of energy levels increases down the group. Atomic radius and ionic radius of the same element. Here we are talking about the atomic radius of sodium and the ionic radius of sodium. For the same metal, the atomic radius is larger than the ionic radius. That is very correct. We can also state that for the same metal, the ionic radius is smaller than the atomic radius. Why is that the case? Metals form ions by losing valence electrons. That's right. So this leads to the loss of an entire outermost energy level. So the outermost energy level, all of it gets lost. It is removed. Thus, the atoms have more energy levels than the corresponding ion. Hence, a larger radius in the atom than in the ion. This is sodium atom and this is sodium ion. So the ion is formed after losing one electron. So let us count the number of energy levels of sodium atom. So sodium atom, this is the nucleus. So it has 1, 2, 3. So we have 3 energy levels. For the ion, after losing one electron, so you see when it is forming an electron, it loses the entire outermost energy level. So now it means that the radius, this is the atomic radius, and look at the ionic radius. The ionic radius is smaller. The atomic radius is bigger. Why? During the reaction, sodium loses the entire energy level. Therefore, if the entire energy level is lost, the outermost energy level is lost, the ionic radius will become smaller. You can look at this. This is the ionic radius and this is the atomic radius. So the melting and the boiling points. Generally, metals have high melting and boiling points. Reason? They have stronger metallic bonds. So metals have, remember, metals, they have metallic bonds between them. A metal and a metal, metals have strong metallic bonds. So the trend down the group, the melting and the boiling points decrease down the group. Why is that the case? The size of the atom increases down the group due to the increasing number of energy levels. As the atomic radius increase, the force of attraction between the positive nucleus and the delocalized electrons decrease. This leads to the decrease in the strength of metallic bonds down the group. Let us consider this lithium, sodium, and potassium down the group. Down the group, there is an increase in the number of energy levels from lithium to sodium, which leads to the increase in the atomic radius, right? Atomic radius increases. So if atomic radius is increasing, then we are talking about a melting point. So the melting point will decrease down the group. Why is the melting point decreasing down the group? As the number of energy levels is increasing, the force of attraction the group, as you can see from lithium to potassium, the atomic size is increasing. Look at the atomic radius from here up to here. It is increasing because the number of energy levels is increasing down the group. So as the number of energy levels increases down the group, the strength of the metallic bond decreases. As the atomic radius increases, the strength of the metallic bond decreases. Therefore, the boiling point and the melting point decreases down the group. Decreases down the group. Conductivity in metals. Metals are generally good conductors of heat and electricity. The reason is that they have delocalized electrons in the outermost energy levels. So the structure of metals contains delocalized electrons which are responsible for conducting electricity. Electrical conductivity increases with an increase in the number of delocalized electrons. So the more the number of delocalized electrons, the better that metal is a good conductor. Now, if we compare sodium, magnesium, and aluminium, we say that aluminium with three valence electrons is a better conductor of electricity when you compare to magnesium and sodium. So magnesium is a better conductor than sodium because magnesium has got two valence electrons which are responsible for conducting electricity. Aluminium is the best. Therefore, aluminium with the highest number of delocalized electrons, that is 3 electrons delocalized, in each atom will have the highest electrical conductivity compared to the rest. So that is it. Let us look at the ionization energy among the metals. Remember what is ionization energy. Ionization energy, we defined it earlier, but I would like to remind you, ionization energy is the amount of energy required to remove an electron from the outermost energy level of an element in a gaseous state. Therefore, ionization energy decreases down the group. So the energy required to remove an electron from the outermost energy level decreases as you move down the group of a metal. Why? The effective force of attraction of the outermost electron or electrons by the positive nucleus decreases with increasing atomic size and the distance from the nucleus. So I want us to consider this lithium, sodium, and potassium down the group. Look at the structure of lithium. Look at the structure of sodium and potassium. Down the group, the size of the elements increases. So it means that the atomic radius is increasing due to the increase in the number of energy levels. So what does that do to the ionization energy? The ionization energy will decrease down the group because the number of energy levels are increasing. Now, what does that do? As the number of energy levels increases, the nuclear force, the force of attraction from the nucleus to the outermost energy level decreases because of the shielding effect. Shielding effect is the blocking. Here there are so many energy levels which are blocking the outermost energy levels from feeling the effect of the nucleus. See this? This is 1, 2, 3, 4. So these 4 energy levels, the three which are inside blocks the outermost energy level from feeling the effect of the nucleus. Therefore, the ionization energy decreases down the group because of the reason we have of metals down the group. Generally, the activity of metals depends on the number of delocalized electrons, that is the valence electrons. An element which has many or more delocalized electrons will require a lot of energy for that electron to be removed. So if we compare, for example, sodium and potassium, they are in the same group. Therefore, that is down the group. If we compare magnesium and sodium, sodium is very reactive compared to magnesium. Why? Magnesium has got 2 electrons in the outermost energy level. Therefore, it requires a lot of energy to remove 2 electrons from the outermost energy, and it is easier to remove 1 from sodium. That's why sodium is very reactive. But for the elements in the same group, reactivity increases down the group. For if we are talking about group 1 elements, that is the alkali metals. If we are talking about the alkaline earth metals group 2, the reactivity decreases down the group. The activity decreases down the group. Why? Metals react by losing valence electron. The ease of losing of the valence electron increases down the group due to the decrease in the force of attraction of the valence electrons towards the positive nucleus. The outer electrons are easier to remove as they are further from the nucleus, and there is more shielding, resulting in a lower nuclear attraction. So let me talk about the shielding effect and the nuclear attraction. So the same group, now we are talking about group 1, that is down the group, reactivity. Potassium is very, very reactive compared to sodium, and the sodium is more reactive than iridium, although they are in the same group. The reason is this. Now, potassium reacts because it needs to be stable. It reacts by losing the outermost energy level. So it requires very low energy to lose this one. Why? Because look at the force of attraction holding the electron here. It's very small. Why? The shielding effect. The shielding is the blocking effect of this in the inner energy levels, which are blocking the outermost energy level. The outermost energy level is blocked. That's what we call shielding effect. So the nucleus is not holding strongly the outermost energy level. But look now at lithium. Lithium, the nucleus is here and the outermost is here. Look at the distance. It is held very strongly. The force of attraction in lithium is very high. That's why the reactivity increases down the group. So this one is not very reactive compared to potassium, for the reason I have given. In the next video, I will deal with the trends of halogens and the trends. Kindly subscribe for me. Do you want me to cry? Then you subscribe for me. I can cry if you want. Please subscribe. Why are you not subscribing, sincerely speaking? Now you are watching something which is interesting you. Instead of subscribing, you just leave it like that. It doesn't cost anything at all. Thank you. Please subscribe.